Hi, welcome back to Imperium Learning. This is the second video in a 2-video series about how to use your vector error correction model to do an OLS regression. Now, jumping straight back into where I stopped off in my previous video, you can see that I noted that the p-value for the second lag of the money supply is suddenly saying that it's significant in explaining the variations in the average house price in the short run. And this is in stark contrast to our Granger causality test, where it showed that money supply in general was not significant in the short run in explaining the variations of the average house price. Now, why could it be that this is suddenly significant at the 5% level? Well, the short answer is that we used the Newey West estimators, if you remember. We used the Newey West estimators, and what does this do? It will basically, even though the coefficients remain the same, the standard errors are different. And the t-statistics are obviously calculated using both the coefficient and the standard error. So if the standard error is calculated in a different way, this is going to produce different values for the t-statistics, and this in turn could alter the value of the p-value. So in most cases it didn't alter the results of the p-values from the vector error correction model, but in this particular case it did alter it. And that is probably explained by the Newey West estimators, which change the values for our standard errors, and this is all down the column. So that's the short answer. One thing you can do for your essay, by the way, when you're analysing this, just to show that you know what you're doing, is just to use a wall test in order to show that these are insignificant in the short run in explaining the variations of your dependent variable, which in my case is the average house price. Now, how do we do that? How do we conduct a wall test? We click on View, we go down to Coefficient Diagnostics like this, and then we click on Wall Test. How do we write this out on using the format that Eviews wants us to? Well, let's start at C4, because C4 has a p-value of way above 0.05. C4 equals, we're going to deliberately skip out C5 because it's got a p-value of below 0.05, but we're going to then go on to C6, and we're basically going to do this all the way down with the exception of C12, because that's the constant. Okay, that's the constant, and we're just going to leave that out, but we're going to do all the other variables because all their p-values are above 0.05. C14, and then finally we're just going to say equals 0. This is an F test, by the way, rather than a T test, and it should have a p-value of well, let's just see what the F test, yeah. So the format of the wall test, I think, was that all of these, because of the way we wrote it out, the null hypothesis was that all of these coefficients equal 0, which is effectively saying that they're, in plain English, that just means that they're all insignificant in explaining the variations of the dependent variable in the short run. And because our p-value, which is right here, if you look, this is the row that we need to be looking at, the p-value is 0.3093, that means that we can't reject the null hypothesis, and that means they're all jointly insignificant. So we would conclude that. That's something that you can write about in your essay. And then finally we can talk about the the global statistics, we can make a brief reference to the global statistics. So in particular, we could talk about the R-squared value. So what we could say, and let's see if I've written down anything in my PowerPoint about this. I think basically the R-squared value, which in this case is 0.6172, let's round it up to 72. This means that my model as a whole can be relied upon to explain 61.72% of the variations in the first difference of my average house price variable. Another thing we could also refer to is the Durbin-Watson statistic. We could talk about how it has a value that's relatively close to 2. That generally means that we can say that there's no autocorrelation between the error terms in time periods t and in the immediately preceding period t minus 1. But be careful, this isn't a great test for autocorrelation or serial correlation, because it doesn't check the autocorrelation between error terms in the present and time periods that go before the immediately preceding period of t minus 1. So in other words, it doesn't compare between, like, say, t and t minus 2, t and t minus 3, and so on. It doesn't do that. So we have to be careful when analysing the Durbin-Watson statistic. But again, you can put that in, use a sentence or two to talk about that. And then finally, what we want to do, well, we want to conduct our residual tests. Once again, I can see that I'm approaching the 10-minute mark, and this is going to take at least sort of 5-6 minutes to go through, so I'm going to wrap up the video here and show you how to conduct your residual and your stability tests. I'm going to ignore this final bullet point here on the wall test. I already showed you how to do that in this video. So yeah, I'm going to wrap up the video now. Bye.